In this lesson, you are going to learn the exception or anomalous case in the first ionization energy across period 2 and period 3. In this lesson, you are going to study the trend in first ionization energy across period 2 and period 3. So in this graph, we have elements across period 2 here. Okay, that is from lithium to neon. Dan kita ada juga elements across period 3 iaitu from sodium to argon. So this is the nuclear charge Z, okay, or the proton number. And this is the value of the ionization energy, the first ionization energy for the respective elements. So, daripada trend of this graph, you can see that when we go across the period, okay, in general, the ionization energy will be increases from left to right of the periodic table. So, left to right ini merujuk kepada case across the period. So, generally, we can say that from left to right of the periodic table, proton number will be increases. So hence, effective nuclear charge ZeF will be increases. So apabila ZeF ini increases, ZeF itu apa? ZeF itu adalah some sort of attraction forces. So attraction between nucleus and valence electron will become stronger. So apabila tarikan di antara nucleus, okay, tarikan di antara nucleus, so this is the nucleus, and the valence electron here will become stronger. So it will be difficult to remove the valence electron because this attraction juga akan menyebabkan atomic size or radius will be smaller. Okay, so difficult to remove the valence electron, so first ionization energy will be increases. Kenapa? As you still remember in our previous lecture, IA is actually the energy required in order to remove 1 mole of electron from gaseous atom. So in this case, apabila tarikan antara these two increases or stronger, so harder to remove this electron. So if the reaction insists to remove this electron juga, maka more energy must be required, okay, untuk nak overcome these attraction forces. So energy required tadi tu merujuk kepada first ionization energy. So untuk case across the period, generally ionization energy will be increases. In this periodic table, these are the elements of period 2 and these are the elements of period 3. So you can see that from lithium to neon, the proton number is increases. So as the proton number increases, the effective nuclear charge also will be increases. And the same thing goes to the sodium as well. Sodium 11 to argon 18. So the proton number also increases from sodium to argon. So this will cause the effective nuclear charge ZeF to be increases. So that will affect the ionization energy across the period, iaitu di mana IE across the period should be increases. Tetapi, if you refer to this trend across period 2 dan juga across period 3, walaupun kita kata generally-nya ionization energy will be increases from left to the right of the periodic table, tapi we can observe a few places di mana ionization energy will be lower than the others. Okay, so di sini di antara beryllium dan juga boron, beryllium is group 2 element, boron is group 13 element. So we should expect boron should has greater ionization energy compared to the beryllium. Why? Because the proton number of the boron is higher than the beryllium. So the size of the boron is smaller than the size of the beryllium. But now, why does the ionization energy of this boron is lower than the beryllium? And you can ask the same question between nitrogen and oxygen. Oxygen is the element in group 16 and nitrogen is the element in group 15. So across the period, we should expect the ionization energy of oxygen should be higher than the nitrogen because the proton number of oxygen is higher and the atomic size of oxygen is smaller than the nitrogen. But then now, why does the ionization energy of the oxygen here is smaller than the nitrogen? And also we will see the same trend in period 3 between magnesium and aluminium and also between phosphorus and sulfur. So in this video, we are going to discuss regarding these abnormalities or a section in the first ionization energy across period 2 and 3. Now, let us study the exception or anomalous of first ionization energy across period 2. In general, we can see that from lithium to neon, first ionization energy of this element will be increases. You can see from the graph and also from the values of the first IE as well. Okay, nilai IE, first IE daripada lithium to neon increases. Okay, tetapi kita ada a few lekuk. Okay, a few lekuk di dalam kita punya trend di sini. So, di mana lekuk tersebut, we can see the lekuk between beryllium and boron dan juga between nitrogen and oxygen. And if you can see from this value as well, kita boleh nampak bahawa value first IE of boron is lower than the beryllium. Okay, so dia macam pelik lah kan. Sepatutnya first IE untuk boron ini should be higher than the beryllium. Kenapa? Sebab boron kumpulan 13, atomic size of boron smaller than the beryllium. So we should expect sepatutnya first IE of the boron ini should be higher than the beryllium. Tetapi this value shows the reverse. Boron has lower IE than the beryllium. So that's why we can see a bit lekuk over here. Okay, now, so what is the reason? So first ionization energy of beryllium is higher than the boron. Okay, first IE of beryllium is higher than the boron. Okay, kenapa? To explain better or to make you understand better, you have to write sama ada SPDF notation, electronic configuration ataupun you can draw the orbital diagram. Okay, tapi in my opinion, it is good kalau you boleh lukis orbital diagram because you can see clearly the differences between the first IE of these two. Okay, so daripada this SPDF notation, you can see that beryllium has 4 electrons, so kita akan ada 1s2, 2s2. Okay, boron has 5 electrons, so you're going to have 1s2, 2s2, 2p1. So kalau awak lukis orbital diagram untuk 2p1 ini, okay, dengan bila awak compare orbital diagram untuk 2s2 di sini, you boleh nampak bahawa this 2s2 mempunyai completely filled 2s orbital. Dan 2p1 here mempunyai partially filled 2p orbital. So in terms of the stability, of course the completely filled 2s orbital is more stable than the partially filled 2p orbital in the boron. Okay, so apabila boron dah pun stable, maka nak buang elektron or valence elektron pada 2s dekat sini, this will be harder. Okay, kerana this valence elektron telah pun mencapai kestabilan. Okay, telah pun stable. Okay, kestabilan apa? Okay, completely filled 2s orbital. Okay, and then untuk 2p1 ini pula, if you draw the orbital diagram, 2p has sebanyak 3 suborbital and now kita hanya isi satu sahaja elektron pada this orbital. So surely this kind of arrangement kita panggil sebagai partially filled orbital and this partially filled orbital is unstable compared to the completely filled 2s orbital here. So, di sini apabila kita ada sesuatu arrangement yang tidak stable ataupun kurang stable, so it is more easier to remove this one electron, okay, from this boron. Okay, so disebabkan oleh 2s orbital in beryllium is more stable compared to the partially filled 2p orbital in boron, maka it is easier to remove this first electron in the boron than the beryllium. So that is the reason kenapa boron first IE has lower ionization energy compared to the beryllium. So more energy is needed to remove the first electron in 2s orbital in beryllium. Okay, ataupun ayat yang terbaliknya adalah less energy is needed to remove the first electron in 2p orbital in boron. Okay, disebabkan oleh arrangement yang tak stabil di dalam boron di sini, maka less energy is required to remove the first IE, the first electron here, okay, in 2p orbital of the boron. So that's why kita akan observe sedikit lekuk di sini menunjukkan bahawa the first IE of the boron is lower than the beryllium. So apa main factor kita di sini? Main factor kita adalah stability of the orbital. Okay, stability dalam electronic configuration. So this is the orbital diagram between beryllium and boron. Okay, so you can see that we have 1s2, 2s2. So this orbital dah pun mencapai stability, okay, due to the arrangement yang kita panggil sebagai completely filled 2s orbital. Dan untuk boron, okay, kita ada one or single electron in this 2p orbital. So this arrangement is said to be partially filled 2p orbital. And this arrangement is less stable. So bila less stable bermaksud lebih mudah untuk kita buang this first electron during the ionization process. So that's why the first IE for boron is lower than the beryllium. Walaupun boron ini berada pada grup 13, ZeV-nya lebih tinggi daripada beryllium dan atomic size-nya lebih kecil daripada beryllium. The next exception adalah between nitrogen and oxygen in the same period too. So di sini juga you can observe from nitrogen to oxygen, sepatutnya when we go across the period like this, the first IE of the oxygen should be higher than the nitrogen. Okay, kenapa? Sebab oxygen kumpulan 16. Okay, ZeV value of oxygen is higher than the nitrogen, and even the atomic size of oxygen pun is smaller than the nitrogen. So kita sepatutnya predict first IE of oxygen is higher than the nitrogen untuk case across the period. But according to this graph, we can see that ada a few lekuk. Okay, ada sedikit lekuk lah. Okay, di antara nitrogen dan juga oksigen di sini menunjukkan bahawa the first IE of the oxygen is lower than the nitrogen. So, macam mana boleh jadi macam ni? Okay. Before that, kalau awak tengok juga daripada these two values, okay, it is clearly show to us that the first IE of the oxygen is lower than the nitrogen. So, what is the reason? Ionization energy of nitrogen is higher than oxygen. Okay, ataupun IE untuk oxygen is lower than the nitrogen. So to explain better, okay, you have to write this electronic configuration, but you can see clearly kalau awak draw orbital diagram. So in nitrogen, kita ada 1s2, 2s2, 2p3. So this 2p3, how does these three electrons are arranged in 2p degenerate orbitals? If you still remember, kita akan isi secara single electron, okay, in same spin. And untuk 2p4 of oxygen here, we will have as much as 4 electrons. So the 4 electrons should be arranged like this. So di sini, from these two arrangements, you can see that the 2p3 in nitrogen, okay, is called as half-filled 2p orbital, and the 2p4 in oxygen is called as partially filled orbital. Okay, and for sure, you have learned before this in the previous lecture. Bila kita ada half-filled orbital, half-filled arrangement like this, so this kind of arrangement juga kita panggil sebagai stable arrangement. Okay, kita kenali sebagai stable arrangement. So half-filled 2p orbital in nitrogen and is more stable than partially filled 2p orbital in oxygen. So kita ada dua jenis orbital yang stable. Okay, yang pertama adalah yang previous tadi, iaitu completely filled orbital, and the other one adalah half-filled orbital. Okay, so disebabkan oleh this arrangement ataupun this electrons dah pun berada dalam susunan yang stable, okay, compared to this one, maka it is harder to remove the first electron in nitrogen compared to removing the first electron in oxygen here. Okay, so due to this reason, first IE of nitrogen will be higher than the oxygen. Okay, sementara dalam oxygen, since kita hanya ada partially filled 2p orbital here, then this 2p partially filled is unstable, bermaksud this first electron, okay, will be easier to remove from this oxygen. So bila kita nak remove satu elektron daripada oksigen, kita tak buang di sini ya, kita kena buang daripada yang berpasangan ini dahulu. So to become O+, which is remove satu electron from the oxygen, you have to remove this electron. Okay, so process of removing the first electron in oxygen is easier than the nitrogen. Kenapa? Kerana orbital arrangement in oxygen is partially filled and it is not stable or unstable. So lebih mudah untuk membuang this first electron. So itu yang akan reflect the value of the first IE untuk oxygen. So here more energy is needed to remove the first electron in 2p orbital of nitrogen. Oh, kalau ayat yang terbalik tu you boleh cakap less energy is needed to remove the first electron in 2p orbital of oxygen. Okay, vice versa sajalah. Okay, so that is the reason kenapa first IE of oxygen is lower than the nitrogen. You can see clearly the exception between nitrogen and oxygen by using this orbital diagram. So untuk 2p3 in nitrogen, kita ada this 3 single electron in same spin like this. So this arrangement is said to be half-filled orbital and it is more stable. Meanwhile for the oxygen, 2p4 in oxygen, okay, kita akan ada this kind of arrangement. Okay, yang ada 4 elektron dekat sini. So 2 ni yang tak berpasangan. So ada satu sahaja yang paired, yang berpasangan di sini. So this kind of arrangement kita panggil sebagai partially filled 2p orbital. Okay, ada correction sikit dekat sini. Please make sure kalau this is orbital diagram, do not ever put the number of electrons at the bottom of the labeling of your orbital diagram. Okay, orbital diagram hanya letakkan symbol of the orbital sahaja and label the electrons on top of it. Okay, dan kalau untuk SPDF notation, then you have to put both orbital dan juga electrons over here. The next exception or anomalous cases of first IE adalah across period 3. So if you can see from this trend across period 3 from sodium to argon, generally we can say that the first IE across period 3 will be increases. Okay, tetapi kita ada a few lekuk di sini, okay, yang mana ini merujuk kepada exception, okay, of the first IE trend across period 3. Okay, so now let's study between magnesium and aluminium dahulu. So ionization energy of magnesium is higher than the aluminium. Aluminium is element group 13, magnesium is element group 2. So supposedly when we go across the period like this, you should expect apabila atomic size of this aluminium smaller than the magnesium, okay, apabila dia punya proton number higher and ZAF is higher than the magnesium, we should expect sebenarnya aluminium ni should has greater IE than the magnesium. Tetapi in real, from the study, okay, it is proven that the first IE of the aluminium is lower than the magnesium. So what is the reason? So you can see clearly by drawing orbital diagram or by writing this as PDF electronic configuration. So this is the electronic configuration of the magnesium, and this is for the aluminium. So as you can see, in the outermost orbital of magnesium, kita ada 3s2. Okay, so for 3s2, this arrangement is so-called as completely filled 3s orbital. Meanwhile, in outermost orbital of aluminium, we have 3p1. So this 3p1 kita kenali juga sebagai partially filled orbital. So between these two, completely filled 3s orbital and partially filled 3p orbital in aluminium, of course, the completely filled orbital is more stable than this partially filled. So, apabila this arrangement, apabila elektron pada 3s2 ini telah pun mencapai kestabilan in its electronic configuration, maka it is harder to remove the first electron in 3s, in magnesium, compared to aluminium. Since aluminium hanya ada single electron in the 3p, so it is more easier to remove this first electron during first ionization energy process. So more energy is needed to remove the first electron in 3s orbital of magnesium. Okay, dan less energy required to remove the first electron in this aluminium. Nak nampak lebih jelas lagi, kita draw orbital diagram untuk magnesium and aluminium. So magnesium has 12 electrons, so you have to arrange as much as 12 electrons in this orbital diagram. And for aluminium, kita ada sebanyak 13 electrons, so this will be the arrangement of the electron dalam aluminium. So here in 3s of the magnesium, okay, you boleh nampak ada 3s2 di situ. So ini merujuk kepada completely filled 3s orbital, yang mana this arrangement is more stable, so harder to remove the first electron from the stable electronic arrangement. Meanwhile, in the aluminium, we do have single electron in the 3p orbital. So this kind of arrangement kita panggil sebagai partially filled 3p orbital, which is less stable and easy to remove the first electron. So this is the reason kenapa first IE of the aluminium here is lower than the magnesium. Yang ni pula adalah di antara phosphorus and sulfur. So di sini, okay, you boleh nampak juga the first IE of the sulfur is lower than the phosphorus. Okay, sedangkan sulfur ini kumpulan 16, phosphorus kumpulan 15. Okay, so sepatutnya first IE of the phosphorus here should be higher than the phosphorus. Okay, should be sulfur first IE is higher than the phosphorus. Tapi kenapa first IE of sulfur is lower than the phosphorus? So let's see the reason. Ionization energy of phosphorus is higher than the sulfur. Okay, phosphorus higher than the sulfur. Kenapa? Okay, we can see clearly from this electronic configuration. So ingat, anytime bila awak nak buat explanation, tapi you are clueless, tak tahu nak buat macam mana, tak tahu apa idea dan sebagainya, always lah tulis electronic configuration of the certain elements. Okay, tak kisahlah when you are about to discuss the trend of atomic radius ke, ionic radius ke, IE or even electronegativity. Kalau awak macam becoming clueless, tulis electronic configuration. So perhaps by looking at the electronic configuration, you will get the idea. Okay, so dalam phosphorus electronic configuration, here we can see that at the outermost orbital 3p, kita ada sebanyak 3 elektron di sini. Okay, dan untuk sulfur, kita ada sebanyak 4 elektron in this outermost orbital. So kalau awak draw orbital diagram untuk this 3p dan 3p4, you akan nampak bahawa this 3p, these 3 electrons in the 3p is arranged dalam susunan half-filled orbital. Okay, dan untuk these 4 electrons in the 3p pula, okay, this kind of arrangement kita panggil sebagai partially filled. So again, between half-filled 3p orbital and partially filled 3p orbital, of course the half-filled 3p is more stable than the partially filled 3p orbital. Okay, so yang ni 3p3 dah pun mencapai stability of the electronic arrangement configuration. Okay, sementara yang ini, this arrangement kita panggil sebagai partially filled, which is highly unstable. So yang stable dengan yang tidak stable. So nak buang elektron daripada yang stable, susah ataupun mudah? Of course lah, susah. So bila susah bermaksud more energy is needed to remove the first electron in 3p orbital of phosphorus. So this should explain kenapa first IE of the phosphorus is higher than the sulfur. Okay, jom kita tengok orbital diagram untuk phosphorus and sulfur. So phosphorus has 15 electrons, so you arrange sebanyak 15 electrons in this orbital diagram. Dan sulfur kita ada sebanyak 16 elektron. Alright, so here in this 3p of the phosphorus, so this arrangement kita panggil sebagai half-filled 3p orbital that is more stable. So it will be harder to remove the first electron in this phosphorus. Meanwhile, in the sulfur, at the 3p orbital kita ada sebanyak 4 elektron. So this arrangement is so-called partially filled 3p orbital and it is less stable. So it is easier to remove the first electron from the sulfur. So yang mana satu elektron or first electron yang kita akan buang? It is this electron. Okay, so first IE is about removing the first electron. Nak buang elektron yang pertama daripada sesuatu atom. So yang manakah elektron pertama yang kita akan buang? Of course kita akan buang yang ini dahulu. Okay, not this one. Okay, yang ini. Kenapa? Sebab kalau bila kita buang yang ini, this electron, okay, bila elektron ini hilang nanti, you akan dapat S+. Dan S+ itu dah pun mempunyai arrangement, okay, seperti half-filled orbital. Okay, 3p3.